Hi, and welcome to Fusion 360. The title of today's webinar is The Future of Connected PCB Design is Here. My name is Edwin Robledo. I'm a member of the family of Fusion 360 here in Autodesk, and I began my career primarily working in the communication industry before joining the Eagle team. My passion for support has led me to publish best practices articles, blogs, and hundreds of video tutorials. I really enjoy hosting live online workshops and on-site Eagle boot camps. I joined the Autodesk family by means of the acquisition of CAD Soft Computer, which developed Eagle. If I'm not tinkering with electronics, you could find me pedaling my iron horse or taking outdoor pictures somewhere in the trails of South Florida. Now, let's go ahead and take a look at our agenda, quite aggressive agenda that we have for today's presentation. We're going to be going over Fusion 360, an overview of the electronic design capabilities, the schematic capture, the circuit board, the 3D PCB. I'll be spending some time there explaining a lot of capabilities that are available on the 3D PCB. We're going to do an overview on the library editor, the workflows for ECAD, NCAD, and PCB manufacturing. And I'm going to go live with Fusion 360 and do a presentation, a short presentation of how to access the electronics and some of the design capabilities live. That way you can do them as well. And at the end, we'll do a Q&A session. So leave your questions for the end, or you could do them throughout the presentation, but I'll go ahead and address them at the end if you don't mind, okay? So during the process of making any product or design, there usually are three primary ingredients is collaboration, design capabilities, the intelligence of the application that you're going to be using, as well as, the capabilities of being able to make modifications to the design when necessary if there's any new updates. But let's go ahead and evaluate some of these electromechanical design challenges that you're currently running into right now. The development of any smart product is going to require the collaboration of multiple disciplines of engineering. Each team is going to use different applications according to the design phase. Collaboration between applications is required to the success of the design. But this collaboration commonly requires to find a file format which all participating teams can actually import and export. This forced you to convert files every time any changes needed to be done to the design. Therefore, too many emails, too many phone calls are required to keep the team up to date. This has proven to be inefficient and quite time-consuming. So what is it we need? According to the VP of LifeFuels, he stated, the interaction of mechanical and electrical system is traditionally challenging. When it comes time to integrate, both teams have a lot of problems. So what is that you need? What do we require? We need a design environment that meets both the electrical and the mechanical requirements of the design of any product. We need to be confident that we're always working with the most recent version of the electrical and the mechanical aspects of our design, and quickly respond to design changes. A true unification of the design process of a smart product has been accomplished with Fusion 360. Fusion 360 Electronic has all the capabilities and resources to design schematic and circuit boards for complex designs. Not only file conversions are no longer needed, all of us will be working with a familiar interface. Fusion 360 is a cloud-based CAD/CAM tool for collaborative product development that combines industrial design, mechanical engineering, machine tool programming, simulation, and electronics all into one software solution. Gone are the days to have to use multiple applications for the development of your next product. Learn one interface and use it with all the tools. LifeView Smart Bottle is a water and healthy beverage infuser with a tracking application. Their senior design engineer stated, Fusion 360 has allowed our mechanical engineer and electronic engineers to work in a collaborative way to fit everything into one small space of our bottle. Now, let's take a look at an overview of the capabilities or an overview of the electronic design capabilities of Fusion 360. We'll start off with the Schematic Editor. Schematic Editor is able to support multiple sheets, has a spice simulation tool so you could verify some aspects of your design if you need a particular signal or something like that. So, and it's able to support digital, analog, and mixed signal capabilities as well. And the best part is that it has full PCB annotation. It has full annotation with the PCB. This means that changes done on the PCB will actually, changes done on the schematic will actually affect the PCB in real time. Now, let's go ahead and take a look at the circuit board. The PCB editor, as we stated already, if you change the name of a signal, change the name of a component, we'll back annotate to the schematic in real time. But one of the best parts that Fusion 360 PCB Editor has, its manual routing capabilities. It has a host of manual routing capabilities. You could route multiple lines. You could route multiple lines guided. We have smooth routing capabilities and many more. So these interactive tools are really enhance the use of the Fusion 360 routing capabilities. But, we do have the auto router, but we like to always let you know about all the manual routing capabilities. That way you're in better control of it. And the best part is, and I'll be talking about this as well a little later, is its annotation with the 3D PCB. So I'll talk about that in a little bit. So the component editor is essential for virtually any application out there for electronics. We have a very elaborate, we have thousands of components, and we have third-party contributors to our library repository as well. So we really have an extensive library. But there will be times that you need to build your own part. We may not have the variant that you're going to use. You may have to build it. So we made it really easy for you to make your own part in a matter of minutes virtually. We include an IPC compliant component generator, which allows you to build your own components easily. The schematic symbol editor allows you to just copy paste the names of the pins directly from the spec sheet and paste it into the schematic symbol editor as well. And putting it all together is actually pretty straightforward. The best part is that the IPC compliant component generator not only creates a 3D model, it actually creates the footprint after just inserting the dimensions from the spec sheet into the calculator. This is a real time saver when it comes to building components. Last but not least is our 3D PCB. 3D PCB, as stated earlier, has true annotation with the PCB editor as well. Assets are actually bodies or extruded bodies. So those vias, those traces, those components, the pins of the components, are actual bodies on the design. Therefore, it gives us the capability of adding of being able to do some simulation, Ecooling simulation to the design as well, which is gets you some very realistic values since materials are assigned to these components as well. So let's go ahead and break these down each one. So let's start with the schematic editor. Schematic editor, we have real annotation, we have the spice, we have net classes. What net class does is that it allows you to assign properties to the connections in the schematic, which are going to be respected by the board, by DRC, as well as the auto router or the manual routing. So if you need a particular clearance, a particular wire width, you could set this up in the schematic. It could be done on the board, but it's commonly done on the schematic side. Now, we have a large repository of components, as I stated earlier. Contributions by Worth Electronics, by PCB Layout, as well as TE Connectivity, and many more are actually being added to our system as well, to our repository, to access to our repository. Now, library updates. Now, we have a really large library repository, but the nice thing is that when the authors of that library make an update, you actually get notified by these updates when you're in the correct dialog box, when you're in the library manager. Therefore, you could guarantee that you could always have that latest version. You could just update to that latest version. Any corrections that they have done or any additions they have done, you could actually have access to them. Now, there's two key points here I really wanted to bring up. Was in the schematic editor, everything is versioned. So every time you make a modification to your design and save, that gets versioned. And you could actually promote any earlier version in case any changes that you've done you want to ignore. Now, the same thing happens if you've given access to your design to anybody inside of your team, which is very easy to do. You could just add their email address if they have their Fusion license, and they can actually make modifications. Well, each version is going to be stamped according to the author and the time, making it really easy to be able to kind of promote that version that is necessary depending at the design stage that you are. So we have that version and that collaboration key point, which I'm going to be addressing shortly again. Let's talk a little bit about the PCB editor. PCB editor has real-time design rule checks. So as you move components, you're going to get or move traces, components, anything that you move, if it's in violation, it will actually get the hatch markings letting you know that there's a violation. So you don't have to stop and wait to run DRC or eventually get DRC. It actually tells you in real time. That way you can make sure that when you place a component, it's actually error-free at the component level. And remember, all these DRC are based on the manufacturing details that you already have inputted when you access the board layout editor. Being able to select a component or a group of components, there's a shortcut there, since you do not have to be invoking for the move command or anything like that. That command is active automatically all the time. As I said earlier, we have some superior manual routing capabilities, some interactive manual routing capabilities, which include the smooth router. So any routes that you already have, if it's possible, it will straighten them out or make them look a lot better, aesthetically better. Also, we're able to route multiple signals simultaneously once you select a group of signals if you want. We also have a multiple signal route capability that is guided. Okay, so you could actually give it a path for all the traces to follow. Now, remember, these are guided. In other words, it's going to try its best to follow that. It's going to do its best to follow that path that you've provided it without any DRC violations. Now, many of us have heard of push and shove. Okay, push and shove and routing. Push and shove basically means that when you're doing manual route, it moves the traces out of the way, moves traces and vias. Well, the development team of Fusion 360 have taken push and shove to the next level. It's an environment setting. In other words, if you're moving any components that have no routes to it, it will actually, placing that component will move traces and vias out of the way to make space for you to accommodate the component. So it does still work with manual routing, don't get me wrong, but it takes it to the next level, which it actually works for the actual component. This is a huge time saver. I don't have enough words to explain, because you no longer have to rip up that whole area, place a component, and then manually route all that. It's actually moving parts, it's moving vias, and it's moving traces away. That way you could fit the component that you need. Now, many of you are working with Eagle and Fusion 360, as I'm pretty sure. It's a really nice workflow. But when you're working with Eagle and Fusion 360, when you push your PCB over to Fusion 360, it's a canvas. In other words, it's a drawing. It looks really good. It sees the parts, but it's not a true PCB. So the traces and the vias are not actually extruded bodies. So one of the benefits of working with a PCB editor in Fusion 360 is that when you push to 3D, you actually get those traces, those vias, as actually extruded bodies. Okay, so that's one of the the primary benefits that we have over Eagle. Now, let's talk a little bit about the library editor, which I had told you before, earlier. As I told you, we have an IPC calculator, and as you could see on my GIF file there, the IPC calculator will actually build a 3D model as well as the footprint of that component. You'll notice that on my GIF file, those hatch lines that you see there, those are actually the footprint, the way it's going to look. That's the markings for the footprint, those construction lines that you see there. Now, creating the schematic symbol is as easy as copy pasting the names of the pins from the specification sheet into your schematic symbol if you want to. It's really that easy to create a symbol. It's pretty straightforward. In addition to creating your standard components, our calculator includes snap lock standoffs and threaded standoffs as well. So if you have we have nylon and we have the metal ones as well. So if you're going to put these standoffs on your circuit board where your board are going to sit, we actually have those that you could actually build them based on the specification sheets, and it will build those for you as well. So we have some hardware when it comes to the PCB, and we have some component creation, which makes it a lot easier for you to work with. So Now let's talk a little bit about post-processing. Post-processing, as we all know, is the action of actually creating the files that are necessary to actually get the boards actually made. Now, we do have a manufacturing previewer, which gives you an idea of what you're going to be receiving in the mail if it's unpopulated, you're going to be getting back in the board. You could take a view from the top as well as from the bottom. And if you go to the different available tabs within the previewer, you're going to get a lot more information about the details, such as how many components, how much copper, polygons. You're going to get a lot more manufacturing data out of that tab that may be necessary for the board house to get the boards made. Now, in the CAM processor directly is where you're going to be generating your Gerber files as your drill files. But not only will generate those, generate the bill of materials as well as the pick and place information, all entitled in one file. Now we have two ways you could do it. We have one-click solution, which actually produces all of the Gerber files for you, including the drill files. Or we have the CAM processor, which allows you some flexibility to be able to make changes how you're going to create your Gerber output. So it's pretty simple, pretty easy, pretty straightforward how to use it. Now, let's go ahead and take a look at the calibration tools that we have in Fusion 360. Fusion 360 actually has access to what we call Fusion Team. Fusion Team actually creates a link in which I can access using a web browser and take a look at the design in 2D or in 3D, and I could actually make modifications, and not modifications, but I could do markups of the design. That way, members of my team can see the progress of the design. Now, these team members don't need to have a Fusion 360 account. They could access the Fusion team through the web access that is available. So you could share your project design progress with managers, clients, as well as manufacturers. Now, if there's anybody that is part of your team and has Fusion 360, they have a bit more capabilities in which makes it much nicer to be able to collaborate. But the best part is that a lot of this collaboration that we're doing is actually versioned. So if any member of the team is making changes or putting some markups on the design on Fusion Team, they actually are versioned. Therefore, I could go ahead and take a look at the progress of the design, reply to any questions there may be, or reply to any recommendations that there are, and we could keep up to date on the commentary of the markups as we go along. So collaboration capabilities are quite impressive using Fusion 360. Now, let's talk about the 3D PCB. Okay, so I'm going to be talking more about the 3D PCB later on in the presentation, but I wanted to emphasize that 3D PCB is not a render. Remember, this is a true possible or virtual representation of your PCB. Bodies and components and vias and traces and core material are elements which are actually extruded into actual bodies. So we get a true PCB, and as you see there, I actually have a Ecooling render, not an Ecooling render, but an Ecooling solve, in which I've been able to present here to let you know more or less what are some of the capabilities I could do with 3D PCB, including collision checks between the mechanical and the circuit board as well. But everything is unified. Unified in the sense that I go from the PCB to the 3D PCB. I could go back and forth, remember, but from the 3D PCB, we could go to the Ecooling, we could go the render, we could go the CAM, we could go the manufacturing, or we could actually insert that circuit board in the design workspace. Best part of all of this is that we've never left Fusion. All the time we're in the Fusion platform system of our design. Now, let's just review some electromechanical workflows that we currently have using Fusion 360 and Fusion 360 electronics. Now, some of the electromechanical options, the workflow options, are relevant to the development team in certain of what is going on and truly guide the design of the next product. Now, here are the three main questions. These are the main ones, not the only ones, but is the circuit board requirement going to determine the size of the shape and the size of the enclosure? is the enclosure geometry strictly going to guide the geometry of the PCB? Or are design flexible? In other words, the design enclosure is going to be flexible depending of how my circuit board is going to be shaped. Are they going to be working with each other? So these questions need to be answered by the team on the electronics as well as the mechanical side, how they want to go about it, because we do have options for you to use depending of your workflow. Now, let's take a look at it. And what I'm trying to prove here is for you to understand that the center of everything of the electromechanical workflow is our 3D PCB. As stated earlier, I have a full back and forth annotation between the 3D PCB and the circuit board. So changes in the circuit board affect the 3D PCB. Changes in 3D PCB affect the PCB as well. Now, here's another observation I had done earlier. Our annotation is always going to be between the design workspace, if I've inserted the circuit board there and I'm using the edit and place capabilities, and the 3D PCB. So therefore, if I've inserted my 3D PCB into my design workspace, if I use the edit and place capabilities, those changes are actually going to affect the 3D PCB, which by then are going to actually transfer over to the circuit board. What I want you to realize is that at no point in time will we ever be working from the design workspace directly to the PCB. That's never going to happen. We're always going to be working as a middle item is going to be the 3D PCB, and that 3D PCB is what all the other teams are going to have. So any modification that happens in the other areas, everybody in our team is always going to have the latest version because they're going to be working with the 3D PCB, and those changes are going to actually trigger alerts to everybody in those teams. What we want to do is we want to capture complex geometries and actually use them in my 3D PCB. I want to hand that off. Traditionally, this would incur in me using a DXF file, in giving a DXF file to my engineer, IGES file to the electronic engineer, so forth. But there's much better method, much more efficient methods now using Fusion 360. Let's take a look at one of them. Create 3D PCB allows me to capture either an enclosure surface, or I could select a profile, a sketch profile, and actually build that into my 3D PCB, and I could take that 3D PCB and import it into my circuit board. That will be my outline. So as you see, I'm not converting anything. I'm actually capturing complex geometry, as you can see here. Now with the create 3D PCB option, every time if I make any changes to my outline, I kind of have to build a brand new branch. It's the only difference here. It's kind of, you got to build a brand new branch. So it doesn't change. It's not really linked because as you could see, my arrows, it only goes like in one direction. Now, to solve that, we have a system called Derive PCB from Sketch. With this option, what happens is that if the mechanical engineer makes modifications to the PCB outline, those changes, those modifications are going to be affected in the 3D PCB, in which the electronic engineer is actually going to notice those changes once he accepts the alerts of the changes that have been done. Okay, so that's the primary difference. So as changes are done, they're linked, and they'll keep on being linked until the mechanical engineer decides to break that link. So that's the main difference between using Create 3D PCB and Derive PCB from Sketch. Okay. Now here, as the name says, it's from Sketch. So this will only work with a sketch body. It does not work with surfaces like the 3D PCB can, which I really truly recommend that you use sketch profiles anyway. Now, let's kind of summarize what we've come to. The design unification, the Fusion 360 truly enables electronic and mechanical engineers to work natively and independently on the same design project within the same design management platform. Some of the key benefits are one common design environment, one common design management system, one design data set with no file exchanges, export, or 3D party integration you've ever needed. Now, the collaboration Fusion offers is complete online experience for PCB, mechanical, and data management, ensuring that every stakeholder is part of the product development cycle. Design changes are automatically managed, enabling you to revise your board shape, component placement update, or modified enclosure. One common design environment, one common design management system, one design data set with no file exchange or exports. With Fusion 360, you have everything under one roof, one platform to accomplish what you want. So what we're going to do is that we're going to go over to Fusion 360 and do a live demo, okay? So I'm just going to turn off the screen just for a second while I set myself up and bring up my Fusion, okay? Thank you. After installing Fusion 360 and running it for the first time, you're going to notice that you're going to be at the design workspace. Design workspace is where you're going to be drawing the majority of all the mechanical aspects of your design, and you're going to be combining them in this workspace as well. You'll notice that there is a pull-down menu here on the left-hand side where it actually lets you switch between other workspaces that are currently available, and we're going to be experimenting with maybe one or two of those as well. To access the electronic design capabilities of Fusion 360, we're going to click on the File pull-down menu and select the option New Electronic Design. Remember, while I was talking to you on the slides, we were always saying that the schematic and the circuit board always keep annotation. It is because of the electronic document. This is what keeps track of any changes between the schematic and the board are actually taking event on both of them in real time. So if I add parts, if I delete parts, connections, and so forth, this is actually where everything, it keeps synchronized between them. Now, I could start a brand new schematic, or I could actually reference an existing schematic. Well, what's the benefit of referencing an existing design? Well, I could repurpose a schematic which might have all the electronics that I already have that I want, but I may need to lay out a different circuit board, yes, because it might be bigger or smaller. So I save all the time of laying out the schematic and just using it as a reference, okay? Well, that's the best part of it. Now, for those of my friends that are using Eagle, you could go ahead and click on here where it says Reference and select the option Select from my computer and go to whatever drive you have your Eagle design files, your schematic in this case, and you could select the schematic. And you could follow the exact same operation for the circuit board as well. Now, I already have an electronic document which I already started working with. So I'm going to go ahead and switch to this tab. You notice that I have a schematic, and it lets you preview the schematic and actually lets you preview each sheet if you want to as well. So let's go over to the schematic, which you already saw. Okay. And you have the panel with the sheets down on the bottom, and you have a couple panels on the left and on the right. These panels are very useful. The design manager is maybe the most useful one. Right now, I have it categorized by nets, and it's showing me all of the connections that I currently have in the schematic here, and it gives us quite a bit of information. If I want to see the components of my design in the schematic, I could actually switch over to parts, okay? And I could do it per sheets, or I could do all the sheets as well, and I could find the part. Let's say I'm looking for a particular component. Let's say I type in C17, for example, or C14. It finds the component, and if I double click it, it actually zooms in on it, and it opens up the property manager. I can make any changes here, maybe change the value, change the name of it, but at the same time, since it's selected, it actually opens up the inspector as well. It shows all the properties of that component on the inspector as well. And down on the bottom of the inspector, it has all the actions that are possible to be made with this component selected or this asset selected. Okay. Now, let me go ahead and click OK. Now, let's say I want to select multiple components, but I only want to select the components. I don't want to select any of the connections. So I could use the selection filter here and select the option part. And now when I define a selection, you're going to notice that the only items or the only assets that are going to show up on the inspector are only the components and none of the connections, all these nets, anything else, none of the text is actually being selected, okay? It makes it very useful for you to be able to make changes, and any changes could actually be done to the selected assets, actually come up down on the inspector as your quick actions. Now, to be able to add components to our schematic, we're going to click on the Add command right here. And as you could see, a set of libraries actually comes up, which are kind of our default libraries made by our team of librarians. Now, if you wish to access additional libraries, you could select here what says Open Library Manager. Now, the library manager is going to scan all the libraries that are currently in my design and provide me a list of the libraries that are used in this design. The ones with the triangle are just libraries that I currently don't have available at this moment. And it's just showing me that little triangle alerting me of it. Now, in use, it's actually showing me the exact same list of libraries that I have in Fusion 360, the same list that I have here. But here I get a little bit of information because I actually scan our database of libraries, and you'll notice that I get the symbol letting me know that there's some updates to these libraries. If I wanted to categorize them by updates, I could actually select them, and I could select the update option if I want to. Now, if there's a particular library that I wish to use, or there's a component and I don't see it on my list that I currently have in use, I could select the Available tab and see many more libraries, maybe hundreds and hundreds of libraries that we have available, contributed by our teams as well as distributors as well as manufacturers that have made them available, and they have access to our repository and they're managing their own repository, which you see here. So these updates that you see on these libraries are actually created by Worth Electronics. They are the ones actually managing this. Okay. Now let me exit here. Now, in the Add dialog box, if you're going to be looking for a component, we do have a search engine. Now, in our search engine, we actually have to use the wildcard. Okay. Yes, because it's just the limitation we currently have. So you just hit the asterisk. Let's say I want to look for some at mega parts, and hit asterisk away again. And you notice that it shows me a list of the at mega components that I currently have in the libraries that I have in use. It will show me the symbol. It will show me the footprint. It will actually show me the 3D model that I have for that component as well. Now let's go over and convert this schematic over to a circuit board. Okay, I'm going to click on Switch to Board. And you're going to notice that the board shows up with all of the components on the left-hand side with the default board outline on the right-hand side. This board outline is actually drawn on the dimension layer. This is layer 20, and it has to be an enclosed enclosure. It has to be closed entirely. And when you see this tone difference between the inside of the circuit board and the outside, they need to be different. If they're ever the same color, it means that it's lost its integrity. Okay. Now this is not the outline I'm going to be using, because I actually want to fit all these parts into my master diagram, which is over here, which is this water bottle, and I actually want to put this in a particular position in this enclosure. So there's many things here in the way. I'm going to turn off a few bodies here to get them out of the way. I'll turn off the bottle, and I'll turn off this plate that we have here, and that way we could expose the bottom of where the circuit board is going to go. Circuit board is actually going to go on this surface. Okay, and I want to capture this geometry, which can be kind of complex if you really look at it. I'm going to capture this geometry and actually use it for my circuit board. Now, the mechanical engineer has already created a sketch profile that has exactly all the openings for the different screws that I need for my circuit board. That way I can lay out my circuit board. So I'm going to turn on the sketch profile. It's going to show me that profile, and you could see it there, that little blue light color. And now I'm going to select Create and select the option Create 3D PCB. And I'm going to select this profile, and I'm going to go ahead and click OK. Now, what this did was that it created the 3D PCB. As you could see, this is quite a complex kind of profile here that if I was to draw this in the 3D PCB, kind of would have been quite challenging to do. So now that I have it in the 3D PCB, now I'll actually want to reference this outline with the circuit board, because this is where I'm going to be laying out my circuit board. This is the enclosure, this is the PCB outline that I'm going to be using to lay out my circuit board. Now, to be able to reference this to my PCB, I'm going to go ahead and select the option right here where it says Link to PCB, as you see here. I'll click on Link to PCB. Okay, and I'm going to go ahead and select, this is the one that I'm going to be using. This is the correct one. And I'm going to click on select. And it was that easy for me to actually capture or project a surface from my master assembly model and get that outline into my circuit board. Now I could start moving the components into the outline. You're going to get this message here that it needs synchronization, but I wouldn't be synchronizing as of yet, but I got to start moving the parts into the board. So I wouldn't push it to the 3D PCB as of yet. Now, I've done some work already on this circuit board. So I already have it laid out, but it's fully unrouted. So let me show you what it looks like right now. Okay. So this is what the circuit board looks like. It's been laid out. I do have some traces already here. So as you could see, manual routing in Fusion 360 has a host of capabilities. So we have our route command. So we have our route manual, differential pair, route, and meandering. So you could do length matching, and you could do length matching for differential pairs as well. Now, I could do fan out. So I could fan out all my, let's say, my ground signals over to a polygon, which could be in the internal layer. I have the quick route as well. Now, before you do any routing, before you actually start doing any routing, I strongly recommend that you run DRC. That way you make sure that you're running into, you're using settings which are manufacturable. So I click on DRC. And if the manufacturer you're going to be using, they may have the DRU file, which is compatible with Fusion 360, which you could load, which is going to have all of their manufacturing criteria or the prototyping criteria. And you could just click here on load. It's going to have the extension DRU as the file if they have it available. Now here we do our layer stack up. I have a 4-layer board to stack up. It goes from the outer layers to the inner layers. If I need blind or buried vias, I would set it up here as well. If I want to do my clearances, which by default are all 6 mil, my distances from the board outline to anything that has to do with copper, the copper dimension, my drill holes. This is my sizes for my minimum width. As you can see, 6 mils. If I want to set up micro vias. So micro vias is primarily if you're going to be doing BGA. So you could drop a via in the center of a BGA. That's when you primarily use micro vias, but you could use micro vias with any surface mount pad as well. So we have our annular rings, which is, it calculates the pad size of our through-hole components on the circuit board and the shapes that we should use. And there's a lot more on the DRC. It's quite simple to interpret. Now, I'd like to show you some of the manual routing capabilities. I'll go to the design menu. And as you could see, it switches over. So I go here where it says route. And as you could see, it automatically adopted 6 mils because that's what I have a size under my DRC. I have my my direction criteria that I could set it. I have different forms of curvature and the shape for my vias, the shape, the drill hole pad size. This is the drill size that's going to be, and then the diameter is going to be calculated based on the drill hole size of the vias as well. So I could go ahead and select any of these components that we have here, any of these signals that we have here. And let's say, for example, we select here, go with a short one. See, now, a nice thing that we have is I'll go ahead and cancel this for now, is the setting down here in the bottom in the panel. So I could do walk around violators, ignore violators, or push violators. So I'm going to just start here with the walk around violators. I think this is a really good choice to use because it kind of contours anything that is on your board already, and it will avoid any errors. So let's say, for example, I start routing here, this line here. And I could, as you could see, it's going around and it won't not violate anything unless I actually allow it to go. So I could just go ahead and do my routing here and go around here, and complete my routing. And I could actually stop here if it's a straight shot. I could hit enter and Fusion 360 will actually invoke quick route and finish the route for me, as you could see. Now, on the quick route, we could do one air wire. So if it's a straight line, like if you're doing a bus line or something like that, it's just a straight connection. So let me say, I think I could do quick route. Now, the quick route, when you invoke quick route, it's actually going to go to the active layer by default. So you'll see here, you have your top router, the top layer enabled. So it's going to try the router on the top layer. because this is my layer stack that I have, but I actually wanted to use any layer. Since I have components on the top, I have components on the bottom, I actually don't mind what layer, but I could be specific what layers I want to go. So I could say, I only want to use the top and the inner layer too. I want to use the top and the bottom layers only. You could specify what layers it wants to use. So let's say on the internal layer, you have a polygon and you don't want to lose the integrity on that polygon. You could force it to only use specific layers. In this case, I don't really mind what layer it goes. So I'm going to select the option any layer for this quick route. And I will go ahead and select this line right here, the signal right here. And you could see that it did a quick route for me. Okay. Now you could always modify this if necessary. I could go to the quick route smoother. And if it's able to optimize that line, it will actually optimize a line if it's able to. Now, there's some more settings I want to show you on manual routing, but I want to do it with the router a bit more, with the board a bit more advanced when it comes to its layout. So I'm going to go to, I have a board not completely laid out, but it's a bit more advanced. So let's go over here to this board, and here we go. So the board is it's done quite a bit. There's still a few traces I want to need to go. But here, what I want to show you is that down here, we have in the panel, we have the push violator option. And this is going to invoke the push and shove. I'm sure many of you are aware of the push and shove capabilities of Fusion 360 when it comes to manual routing. So I'm going to select route, and I'll select here. And as you can see, it begins to route, and it's actually pushing vias and traces out of the way. But what I really wanted to show you here was if I actually use and I keep that environment setting and I select move and I select an asset here, like this component I have here. So now look what happens with that environment setting. It actually moves traces if I try to move this component throughout my design. This is a really big time saver because if you do any type of updates to your design, you know for a fact that there's going to be times that you need to add a component. And a lot of times you would have to rip up many traces to make space. Here, you're not having to make any space. You're actually able to move the part around and place it wherever it's necessary. So it makes it extremely convenient for you to be able to move parts this way. So I just wanted to bring that up here really quick. Now I'm going to go ahead and save what I've accomplished so far. And I want to send this over to the 3D PCB. I want to see what's my progress on the 3D PCB. I want to take a look at the board in that environment. So I'm going to select here, view in 3D PCB. Okay, now that the 3D PCB is concluded, you'll notice that we have a really nice realistic look of our board. Now, this is not a render, as I stated earlier. These vias are actual extruded bodies. Every trace is an extruded body, as you can see here. The components, by default, the ones that we use in our libraries actually have materials assigned to them. So if we were going to do an Ecooling analysis, all the materials already have been assigned, including the core and the pre-preg material for the circuit board as well. So now, one nice thing that we have is that if you want to make a modification to the circuit board in this environment, it's actually possible. I'm just going to use R55 here, and I'm just going to move it as part of our demonstration. So I'll click on move, and I'll select R55 in case there was a violation, and I can move it horizontally, vertically, or I could just use our free hand here, and I'll select it. Now, when I do this, before I select OK, I want to select the option to update the circuit board, and I actually want it to reroute again. Okay, I want it to reroute it on the circuit board. So I'm going to go ahead and click OK, and this is R55. And now let's just go ahead and it's going to cycle between the PCB and the 3D PCB and update everything. So it's just going to take a few moments. Notice that the pads actually updated, letting me know that it's executed successfully, the command that we aggregated. So let's take a look at the PCB. So let's go over to the PCB and take a look at R55 as well. Okay, so let's just go ahead and use our our design manager here, and we have it by devices. And let's just go ahead and type R55 here, that we could actually zoom in on the part. There it is. And there is new location and the properties for the new location on the part. Notice that the traces actually have been updated for this component. Okay, so let's go ahead and click OK. And Now, throughout the whole experience on working on this board layout and the schematic, one thing I wanted to point out is that at every stage I've been saving, I'm constantly saving, that way it writes the file, everything gets versioned. Absolutely everything is getting versioned. So if I'm actually collaborating with multiple users into this project, their names are going to show up as well as a version is going to show up as well as mine. So let's say, for example, on the circuit board, I'm already at version 18. So you'll see here, I could actually view any of them and see the progress that I've done. And if I want to promote any of these earlier versions, yes, because the changes that I did on a version afterwards, I want to ignore them, I could just go ahead and select here and promote an earlier version. This can happen at times when if somebody made changes that were not desirable to the design and you want to go to an earlier version because that was the one that you were working on and you want to continue working on that one, here you could actually do that promotion as well. Now, adding people to your project, that way they could have access to it, is pretty easy. The only thing they have to have is an Autodesk account. And so right here where it says people, an Autodesk account basically is an email and a password, and you're going to select their email address here. If they have, and they're going to get an invitation. If they have Fusion 360 installed and they're a registered user of Fusion 360, they're going to have access to your hub, and that hub is going to be showing this project folder for them, which they'll be able to access it and make modifications to it as well. Okay, so this is how we kind of control it. This data panel is where you're going to create your projects and your folders for your projects and keep everything neatly organized. So it's actually pretty useful. Okay, so now what I want to do is we have a 3D PCB, and I wanted to show you really quick the Ecooling capability. So I have the 3D PCB, as you could see here. Okay, that's our circuit board, their 3D PCB. And now what I want to do is I want to do an Ecooling solver for this. So what I'm going to do is I'm going to switch from the 3D PCB. I'm going to go over to simulation. Once we're in the simulation workspace, you'll notice that I've already assigned heat loads to many of the components that we actually have. And I've already ran the solver. So now I'm going to go see the results on my solver. As you could see, we're seeing kind of a snapshot of the results that we have from running that solver. So I just wanted to just do this quickly. That way you can have an idea of how this works, okay? Now that we've accomplished the results on the Ecooling, I just want to go over our last topic for today's presentation. I'm going to just go ahead and finish what we've accomplished so far, and I'm going to just go back to the 3D PCB. But in this instance, I'm going to go to the 3D PCB because I want to show you more of the collaboration tools for users of Fusion 360, which can also access Fusion Team. It's included with the subscription. So let me move over to the 3D PCB that I've been using. Okay, so I'm going to go ahead and click here where it says open in the web. So it's going to open up this current project and all the subfolders on the Fusion Team website. You'll notice that now I've landed on the same folder. This is the project. And I've landed on the exact same folder which I was in Fusion 360. And this is the entire content I have under this path that I have here. So what I'd like to show to you is all those members that I've added to this project, I could actually administrate their access here where it says project members. So I could change their administration to editor or to viewer. Okay, let's go ahead and return to the content. When you go back to the content, you'll notice it'll bring us to the root of the project and all the subfolders in the project. I'm going to go ahead and just find the project that I wish to load, which is Life Fuels, and we're working with a board called Condor. And on Condor, I'm going to look for the routed board, so which I have it completely laid out here. And this is going to load the 3D PCB as well as the 2D PCB. In this case, I actually want to do an overview of the 3D PCB. Nice thing is that in Fusion Team, everybody has access to it. So if they have a Fusion 360 account, they will be able to access this. If they don't have a Fusion 360 account, the only thing you need to do is send them a link for here. You just copy paste the link and send it over to them, and they will have access to your project as well and be able to see the progress. So you want to be able to share this with maybe contractors, administrators, part of the executive team, whoever is involved with the progress of this product that you're about to develop. Now, we could have a dialogue going on. As you can see here, there's a little dialogue option in which it actually keeps track of the commentary that's going on. And this is actually version, and there could be discussions based on here. As you can see, we have a reply option. Now, I could do some additional markups. I just want to show you how to do markups. So click here on callouts and click here. Just kind of drag a markup here. Okay, and it's that easy. And once I save, you'll notice that it actually builds it here. So anybody else that have access to here, this is going to be opening up. The nice thing is that it actually is going to build and reply, and the dialogue is going to keep on being constructed. And if we go over to overview, you see the progression here as well. The comments carry around here. So the nice thing is that you could easily collaborate, and you could determine the level of collaboration you want to do. So this is everything I wanted to cover for today's presentation. So we're going to move over to the Q&A session. That way I could address any questions you may have with us. So thank you for joining. I'll be right back. Let me set myself up and close this out. Thank you.